crystal-like object rotating with precision, heating and cooling in ways no natural rock should. What if I told you that we've just seen with our own eyes a piece of another star system? Not a blurry streak of light, not a trace of radiation or some mathematical anomaly, but a crystal clear image of an object that came from the deep beyond. When the James Webb Space Telescope locked its gaze on Oumuamua, everything. This wasn't just another comet or asteroid. This was something else. Something that forced scientists to rewrite the rule. First spotted in 2017, it had already stunned astronomers with its interstellar trajectory, speeding through our solar system at an angle and velocity that screamed, "I'm not from here." But until now, all we had were guesses, hypotheses, stitched together from distant measurements and educated assumptions. Then Webb saw it, and what it revealed was nothing short of a cosmic bombshell. No cigar-shaped rock tumbling aimlessly through space. Instead, what appeared on the screen was a faceted, prismatic form, like a jagged shard from a shattered mirror, glinting in hues of ice blue, iron gray, and hints of oily iridescence. Its surface looked engineered crystalline angles, sharp symmetry, and zones that reflected light like polished metal. Not random, not natural, at least not in the way we understand nature. And when Webb's sensors dug deeper, things only got stranger. The object's chemical makeup defied everything we've seen. Solid hydrogen, exotic ices, nitrogen-oxygen compounds in unfamiliar bonds, the kind of molecular mix that shouldn't even exist side by side unless forged in unimaginable environments, maybe the freezing shadows near a failed star, or the high-pressure chaos near a gas giant's edge. Spectral readings suggested something more. Regions of intense heat retention, as if the object were internally insulated or perhaps even hollow. A porous matrix could explain some of it, but a hollow core, that opens the door to ideas we've barely dared to say out loud. Then came the motion data. No chaotic spin like we see with most rogue space rocks. Oumuamua rotates smoothly once every 8.3 hours along a central axis. That suggests internal cohesion, maybe even a structure. Loose debris doesn't move like that. And here's the kicker. It heats and cools too slowly for its size. That's not just weird, that's revolutionary. Either it's built from a material we don't understand, or it's hiding something beneath the surface. Some scientists whisper of metallic strength or chemical bonding. Others wonder quietly if this might be artificial. But even if it isn't, the implications are massive. This object is a relic, a time capsule from a system we've never seen. It may have wandered for millions, even billions of years, carrying the molecular fingerprints of its birth system. And now that we've seen it in detail, we know this isn't an isolated event. If one such traveler has entered our solar system, others will follow. Oumuamua has already forced planetary science to expand its models. Before this, we thought solar systems were mostly self-contained. Now, we realize the galaxy is interconnected, trading fragments of planets like messages in a bottle across oceans of stars. And maybe, just maybe, some of those bottles carry more than just rock and ice. Maybe they carry the seeds of life. But the real shocker? What the James Webb Telescope didn't see. No venting gases, no comet-like tail, no visible propulsion, and absolutely zero signs of biological activity. Yet, there it was rotating with precision, its shape unnervingly structured, its materials organized in a way that challenges every known category of celestial object. It doesn't behave like a comet, asteroid, or dwarf planet. It might not even belong in any existing class. Scientists are now quietly murmuring about a new type of interstellar phenomenon one we've never encountered before. Webb's image didn't just capture a space rock, it captured a paradox. Its sharply defined reflective zones weren't blurred by micrometeoroids or radiation damage like you'd expect after millions of years drifting through space. In fact, the surface was unusually clean, dust-free, like it had been maintained or was somehow self-cleaning. That's not just odd, it's almost unnerving. Could it be coated in materials that shed interstellar dust? Could internal gas pressure push particles away as it spins? Or could there be some unknown mechanism at play? The deeper researchers dug into the data, the weirder it got. The way it refracted infrared light was unlike anything seen in natural bodies its size. This wasn't just reflection, it was refraction, as if light was bending through microscopic prisms embedded in its surface. Think crystalline structure, but alien. Attempts to recreate the light signature in labs failed. Even the most advanced simulations couldn't mimic the abrupt transitions in reflected wavelengths Webb recorded. Which raises an even bigger question. What kind of environment could form such materials? Some hypothesize pressures near neutron stars. Others look to magnetic white dwarfs or areas of deep interstellar radiation. We're talking places we've never explored, extreme, chaotic regions that rewrite physics as we know it. And yet, Oumuamua survived it. It endured ejection, interstellar drift, cosmic rays, and micrometeorite strikes, and came out the other side in one coherent piece. That makes it more than a visitor, it makes it a survivor. Possibly a messenger. Astrobiologists are now eyeing it not as an object, but as a vessel. With layers of organic compounds, radiation-hardened surfaces, and an internal structure that could protect fragile molecules, Oumuamua might be the best candidate yet for something even bigger than interstellar travel. Panspermia. The theory that life or the ingredients of life can be spread across the galaxy by natural celestial bodies. Imagine if this object had collided with a young Earth or Europa or Mars, it could have seeded the building blocks of biology. That's not science fiction. That's now a serious possibility under investigation. And it's pushing scientists to rethink everything: planetary ejection mechanics, galactic chemistry, even interstellar archaeology. Because yes, there's now talk of a new field entirely dedicated to analyzing potential non-terrestrial artifacts. Oumuamua is now its founding member. And while most experts still lean toward natural explanations, a small but growing minority are keeping the door open just a crack to the idea of intelligent origin. Not because they want to believe, but because the evidence refuses to fit neatly into what we know. Maybe it's not artificial, but it's certainly not ordinary. And that's enough to make the world stop and wonder. This wasn't just an image. It was a revelation, a shimmering, faceted mystery that drifted silently through our sky, then vanished. But the questions it raised? They're just beginning.